Hi, this is the demonstration of the state chart of Team Interrupt Junkies. So we are considering this sample map here for a line following robot, and on the left is the state chart of the robot. So we are modeling all sensor inputs as binary 0, 1. So the total sensor input would be a 5-bit string. And similarly, we are modeling all motor outputs as binary 0, 1. So motor outputs should again be represented by a 3-bit string. First bit indicates direction, 0 for backwards and 1 for forwards. And for each motor, there is a single bit, 0 for no power and 1 for full power. So let us consider this sample map. So we assume that at the start, there is a horizontal line, horizontal or vertical line, a straight line which indicates that all 5 sensors are 1 on them. And this is indicated by this transition at start. So if we take this transition, so now we are in the forward state, and this will correspond to the robot being on a straight path of this curve, or a straight part of the map, although that can change. So for instance, suppose the robot is at this point, then here it will sense 0, 0, 1, 0, 0, and that will correspond to this transition, which is the looping transition here. So this will keep triggering until the robot makes its way here. And at this point, the sensor input will be 1, 1, 1, 1, 1. That is all ones. And in that case, it will transition to this state, which is the T state or the stop state. The reason we have distinguished between those is because 1, 1, 1, 1, 1 can also happen in a case where the robot is at the end of the line, but we'll come to that later. So in the T case, what we'll do is we'll turn right slightly. So that is indicated by these two actions, 1, 1, 0, which is the same as saying we'll turn the left motor, we'll run the left motor at full power forwards, and after followed by the right motor backwards at full power. So that will turn the robot rightwards, and as long as it's not straight line paths as well as not all ones, we'll keep turning. So the robot will eventually turn all the way rightwards here, and it will be pointing in this direction. And at that point, the sensor input will be 0, 0, 1, 0, 0, and the robot will continue. So this will happen a few times. And then after that, 0, 0, 1, 0, 0 happens, which corresponds to the robot being on the straight path. So let us now assume that the robot, while traveling on the straight path, has some kind of deviation towards the left or right. So this could be, say, for instance, 0, 0, 1, 0, 0 or 0, 0, 0, 0, 1, which corresponds to the robot veering slightly to the left. So if it has veered slightly to the left, we would like to make sure that it comes back on the path by doing a slight right tilt. So let us take this transition. So in this case, it will be a slight right tilt. So by a slight right tilt, we mean that we will actuate the left motor forwards by a small amount. So that's equivalent to the action 1, 1, 0. And we will continue doing that until the sensor input becomes 0, 0, 1, 0, 0 again. So that happens a few times, and then this. So now we have veered off the path and come back on the path. And now suppose we are reaching here. So in this case, the sensor input would be something like 1, 1, 1, 0, 0, which corresponds to this transition. So let us take that transition. In that transition, there are two possibilities. Like the way we have designed it is we call this a state as left turn / overshoot, and the reason for that will be explained shortly. So here what we do is we continue going forward, and the reason for that is we want to be able to handle a particular case. So our overall strategy with this state chart is that we always take the rightwards path in any intersection that we encounter, and in this case the rightwards path would lead us here, which is onto the straight segment. So this straight segment will again have 0, 0, 1, 0, 0. So let's take that. And now we are back to this forward state, and we are here in the path. So let us continue here. So now we take a forward step again. And now suppose we take another forward step, which is, and we end up outside. So outside, the sensor input will now be 0, 0, 0. So that means we'll be taking this transition. And now the robot knows that we are outside. So now what we'll do is we'll take a U-turn, because we know that we have stepped over the end of a line. So we will, for a U-turn, what we'll do is we'll first reverse back So reverse back is indicated by the action 0, 1, 1. So that's reversing both motors at full power. And we'll assume that we're reversing for some distance until, so that's a few transitions of this until we reach the line back, which indicates transition of 0, 0, 1, 0, 0. And once we're here, now we'll have to turn around. So now we'll start turning leftwards. We'll start turning leftwards. So that's the action 101 followed by 010. So 101 is actuating the right motor forwards, followed by activating the left motor backwards. So that we repeat again and again while we are not over the line until we reach the line again. So this happens a few times. 0, not 0, 0, 1, 0, 0. That is, we're not on the line until we come back to the line, which is 0, 1, 0, 0, 1, 0, 0. So now we are over here and we are facing this way, upwards. So now we start going forwards again because that is what we do here, 1, 1, 1. And we assume that we see the line a few more times until we come back to this intersection. At this intersection, our reading will be 0, 0, our reading will be 0, 0, 1, 1, 1. So it will be this transition. So let us take this transition. So what we want to do is take a right turn here. So here we'll start turning right, and the way we'll do that is we'll actuate the left motor forwards and the right motor backwards in sequence a few times until we center the sensors again. So that will be this, and now we are on this intersection and facing this way, and now we'll keep going forward, and we'll keep going forward until we've hit this point. At this point, our reading will be 11100. So let us take the transition. So now we are back to the state called left turn overshoot. And this time, as before, we will be taking the forward path. We will continue going forward. Here, however, when we go forward, then our sensor input will be 0, 0, 0, 0, 0 because we have gone off the line. And once we go off the line here, we know that we were supposed to have turned left instead of going straight because there is no straight path present here. So we will come backwards. By going backwards, we will do the action 0, 1, 1. And we will keep doing that until we are back over the intersection. Now that we are back over the intersection, we know that we should have taken the left turn. So that is what we will do here. We will do the action 101, which is actuating the right motor forwards, and then 010, which is actuating the left motor backwards. And we continue doing that until we are back on the line. So now we are at this intersection and we're facing that way. And now we can continue going forward as before. So in a similar fashion, we can trace the entire map. And so we keep going straight, and we can the straight path will again be 0, 0, 1, 0, 0. And then in a similar fashion, when we encounter this intersection, our reading will be 0, 0, 1, 1, 1. Let us take that path. So as I explained before, we are always taking right turns. So here we'll start turning right, which is 110, actuating the left motor forwards and the right motor backwards. And we'll keep doing that until we're aligned over the line again. So now we are at this point and facing rightwards, facing this way. So we keep going forward again. So that's 0, 0, 1, 0, 0 a few times until we arrive at this intersection, which will be 0, 0, 1, 1, 1. And as before, we'll take a right turn again. So a few more activations of this transition followed by this transition. So now we are at this intersection facing downwards. So we'll again keep going along this line 0, 0, 1, 0, 0. And it's possible that we might veer the other way. So 1, 0, 0, 0, 0 or 0, 0, 0, 1, 0, 0. So that's equivalent to veering leftwards. Veering rightwards of the line. So if we have veered rightwards of the line, we want to left tilt. So for left tilt, we would need to actuate our right motors a little bit. That's equivalent to the action of 101, which is actuate the right motor forwards a small amount. And we'll keep doing that until we are back on the line. So that's a few actions of this transition followed by back on the line, which is 0, 0, 1, 0, 0. So in a similar fashion, we can traverse the entire straight segment, and suppose we reach this intersection. So there the sensor input would be 0, 0, 1, 1, 1, which again corresponds to right turn, and so all the formalities of right turn happen again. And now we are almost at the end. So a few more, like the straight segment is again traversed by transitions of the veer left, veer right, and straight. So now suppose we are at the end here. So when we step into the end, then our reading will suddenly become all ones because the end is a solid line, solid patch. So in the case of all ones, we'll arrive back into the transition called T-stop. And at this point, what we'll do is we'll try to turn rightwards. which is the 110 and 001. And after trying turn writers, we'll still see that we're getting all ones because we're at the end. So that means that we must have reached the end patch because that is one solid patch, and so we will stop.